Hey guys, welcome back to Tin Man Sam's YouTube channel. Going over the Jeep Willys engine build. Usually I'm in the shop, but today we're going to take it into the office so I can walk you through what I do with all of those measurements that you guys see me film. So real quick, want to show you what I've put together. Background behind this is, recently built a Ford FE motor. It was the first motor I built since I was in high school. Went to find kind of a template for the spec sheet so I could record my dimensions and make sure everything was within the spec. Didn't have much luck finding anything digital other than templates you can print out. So I did that and did everything, the old fashioned way with terrible machinist handwriting like everybody else, and knew there was something needed to be quick and easy and better for my next build. So that's what you're looking at now. This is our fancy Excel template. Used my, long corporate America career Excel skills developed there to put this template together. And basically what we've got is some inputs and some outputs. The things we input are going to be in the yellow and the gray, and these are going to be our actual measurements and our specs. And then the output this is going to give you is the green and the red, whether you're within that spec, and so forth. Generally speaking, I got a nice legend up here that's going to tell you what those colors mean. But generally speaking, the first way you're going to use this, you're going to go in and you're going to put your specs in the gray boxes. You can see we've got these gray boxes here, and you're going to come in here and put the spec that you find for these items. These specs can be found in the Willys service manual. You can see generally I have two columns. The Willys service manual and then kind of the machinist manual. The machinist manual is typically the rules of thumb that a machine shop's going to use when they perhaps they're working on a piece of equipment. There's a lot of motors, a lot of engines out there that are not as well documented as the Willys motor, the 134 Go Devil. And machinists don't just give up when that happens. They have ways of understanding how machines are supposed to work and specifications that they can generate when they don't have those provided by the manufacturer. And that's what I did. And my goal is to typically be green in one of the two at least at a minimum. That way we know our engine is within some spec. It may not be the Willys factory spec, but it's within a spec that's reasonable. And in the rare case that we're out of spec, we understand the magnitude of that, and we can either live with it or understand the cost in the struggle to fix it, and whether we want to do that or not. So that's in a nutshell how this works. I'll go through right now where we're at for the Jeep Willys engine. This is a work in progress. It pretty much matches where I'm at with the build. So I've divided this out between the rotating assembly and the valve train. And for the rotating assembly, we've got obviously the main bearing clearances, the rod bearing clearances, and the thrust bearing clearances. As the build progresses, we will add the piston bore and piston, as well as the ring gap measurements, and make sure those are all within specification. I've also got in here the method which we use to measure these. So a dial bore gauge and a micrometer for the journal, the dial bore gauge for the bore of the bearing, and the micrometer for the crank journal. That way, if you're new to this, you kind of know what, tools to use and how that works, and the videos all kind of tie into that as well. Looking at the main bearing clearance first, you can see we measured the bore first with the bore gauge. We measured the journal with a micrometer, and some neat Excel formulas tell us the difference between those two, which is our clearance. We have the min max clearance from the Jeep's Willys service book, and then we have the machinist manual rule of thumb. This would be the perfect ideal clearance, and that's typically a thousandth of an inch per inch of journal diameter. And you can see we passed the Jeep Willys service manual no problem, and we're off of perfect by about a half a thousandth. So I set this red and green conditional formatting to go red if it's more than half a thousandths off of ideal. And half a thousandths isn't very much, guys. If you're within half a thousandths, you're pretty close, unless we're talking about a very very high revving engine. Um, so yeah, that's kind of the mains, and then the rods. Come through the rods, and we're a little bit the clearance is a little bit heavy for factory spec, but going to the machine manual, we're within spec on that. About less than half a thousandths variance from the ideal clearance, and you can see the number 4 we do have a bit of a problem. We're just slightly over tolerance. This is the one red that I can't get rid of, and that's a challenging one. I can see what happened. Our bearing bores all measured the same, but our crank is ground just a smidge, not even 3/10,000ths of an inch smaller on that number 4 journal, and that's kicking us out. But the challenge is to correct that is I would have to go in there and regrind that entire crank and try to hit these again. And heck, I might miss another one at that point in time. And beings that were less than 3/10ths of a thousandths, and this is a very low revving engine, we're going to be okay with that, and we're not going to go into that extra cost and extra hassle of regrinding that crank, that rod journal on that crank. We will live with that very small, out of spec, you know, variance there. Haven't measured thrust yet. We haven't completely assembled the rotating assembly, so I just have a preliminary measurement in there. I think I was measuring 9 without having everything installed completely torqued down. So I think once that torques up, we will be fine. And if not, we can put some shims in there to get there. So not too worried about that. But yeah, I got thrust bearing clearance in there, and then more to come on rotating assembly. We will add the piston and the bore clearances. Then we get into the valve train. I've got the valve guide clearance. We used a couple methods. We used the dial indicator method, and we're able to get green on at least one category for each. And then we also used the valve guide clearance ball gauge method, where we stuck ball gauges down in the valve guide in 3 different locations and measured those, averaged those, and you can see on that one we failed the Willys spec, but we pass across the board on the machinist manual. I think that Willys spec may be a typo. That's a pretty small clearance for any valve guide, compared to what on an intake compared to what is generally accepted. I don't. I feel like that may be a typo from the Willys manual, but who knows? I know they certainly weren't getting them that close in the field when they were rebuilding these over in Europe. How they probably just threw in a whole new motor back then. But get down here to the valve concentricity, and this is one where I'm struggling with. I've measured the concentricity, and generally there is no Willys spec for that. It's not something a lot of people measure. But general guidelines are that you have 1.5 thousandths per inch of valve diameter. So I've done all that math and calculated out a spec here, and we're measuring in where we should be measuring in, right around 2 thousandths of an inch is the limit. We're measuring around 3 to 6 thousandths of an inch. And that's turning me red. And that's a relatively easy fix. The answer is to go back there and cut those valve seats. But the reality is I've already had them cut twice, and from at a good professional machine shop, and they struggled to get them right the first time. So do I let it ride? I don't know. I'm going to do some further testing on the valves. I'm going to assemble everything, turn the engine upside down, and pour some mineral spirits in the heads and see if they leak mineral spirit. If they don't, I'll probably let this ride. This is something that can be fixed later on, just by removing the head, which is very easy on a Willys motor. So if I can't live with this, or I think we're gonna have a problem, or and I think we're okay based off of mineral spirits not leaking out of it, we'll let this ride. Real quick, as we approach the 10-minute mark, I'm trying to keep this under 10 minutes. This next tab on here is a running list of what it took to get where we're at. So from scratch, if you don't have the tools and everything, you're looking at $2,900 build on this Willys motor. But if we assume that you can borrow the tools, or you already have them, right now, I think to get this motor built, I'm right at $2,300. Now, almost half of that is machine work. We had a terrible block. It needed, some cracks fixed in it. It needed a sleeve pulled out, new bore, new sleeves put in, those sleeves bored. So your block, odds are, is going to be better than that. But generally speaking, I keep this digital copy of my engine build, which is going to be available for my brother-in-law, who I'm building this for. To when he passes that vehicle on to his son, he'll have this digital file that says everything that was in the engine and how it all measured out. And that's an important thing to have on these old vehicles as you work on them, and something that's pretty easy to do. So I'm going to load this in the descriptions. I'll put a link to my Google documents, where this is shared with everybody, so you can download this. Again, I've got some updating to do to add some other measurements, but that'll be available to use for your own builds. Thanks, guys. Appreciate it.